Okay, today we're going to look at piecewise functions, and we're going to do a bunch of different things with them, including writing from a graph, writing what the piecewise function is. So we're going to look at two problems and just a bunch of different questions on them, a bunch of A, B, C, D's, whatever. So let's start with, let's go ahead and graph piecewise function. So sketch this. Okay, put 3, 1, 2, 3 in the x direction. 1, 2, 3. And then let's go back. -1, -2, -3. -2, -3. 4 up. So 1, 2, 3, 4. 1, 2, 3, 4. Okay, so I'm going to draw a graph, a piecewise function, and then I'll ask a bunch of questions about it. All right. Okay, so plot -2, 0. Let's see, 1, 4. So 1, 4. And then 3, 1. So this will be a relatively easy piecewise graph, so we get an idea of what and how to answer what I ask. Okay, go ahead and draw these will be straight lines. So draw a straight line. Oops, straighter than that, but draw a straight line. And then another straight line. So these are two lines. Okay, so question A. I'm going to let you get caught up there, graphing that. Okay, and these are the type of questions that will be asked on a test or quiz, same type of deal, and your homework. Actually, these two problems that I do, real similar to your homework. Okay. All right, so first question. State the open interval where, and I'll explain what this open means. State the open interval where f of x is increasing. Okay. Let me explain what that question is and how to answer it. State the open interval. Well, first of all, open meaning, do you think we're going to use square brackets or curved brackets on my interval? If it's an open interval. Curved. So it'd be a curved. And state the interval, state this open interval. So we're going to describe this by the domain. Okay, so put it above this open interval, put domain in parentheses there. So we're going to describe the domain, and these are x's. I'll put an x right there. We know that, but I'll put it there in our notes. So we're going to describe it by x-axis numbers, -3, -2, -1, 1, 2, 3, 0. Okay, so state where this graph is increasing. Okay, so let's look at the graph. And increasing meaning from left to right, the way you read, where is it going up or have a positive slope? Okay, so we can all picture where it's increasing, can't we? And if you had to point to it, where would it be? Be on the left side or the right side? Where is it increasing? The left side, over here. Okay, so they want us to state where it's increasing. Well, we're going to describe it by the x-axis numbers. So you could actually even cover up the y-axis, and just by those numbers on the bottom, describe where it's increasing. So you guys tell me in words. Where is it increasing from? -2 to 1. Good. That's our answer. That's where it's increasing. Common mistake, just to point this out so you can kind of see. Some might go, oh, it's increasing right here, so it's increasing from 0 to 4. Well, what's wrong with that?
That's the y.
Yeah, those are the y-axis. I want to describe it using the domain, the x's. Okay, so yes, you're absolutely correct. It's increasing from x is -2 to x is 1. All right, so, and it's an open, always curved. So -2 to x equals 1. That's where it's increasing. Okay? And I'll tell you why I put curved in a second. Okay, B, let's say same question. So I'll put in quotes, state the open interval, okay, where it's decreasing? Decreasing. Okay, so we want to know or describe where the graph is decreasing. Well, if we look at it, again, describing by the x-axis number, where would you say this graph is decreasing? 1 to 3. X equals 1 to 3. There we go. And do we put curved? Yes, always curved. So from x equals 1 to x equals 3. I know it's a closed circle there, but just always open when you describe increase or decrease. Okay. One of the reasons why we have it always curved is because let's say we did put a square bracket there, okay, closed on 1, so it's increasing at 1, and then we put a square bracket there. It can't be both increasing and decreasing at the same time. Does that make sense? So we just put it all open, all open. Okay, C, domain range. Okay, something we've done quite a bit here. Okay, now this, if it has to be a closed or open, then you got to put it curved or square bracket. Okay, so domain. So what's our domain of x values of where we see this graph? What's our domain? Negative 2 all the way to 3. Square or curved? Squared. Yes, there is a negative 2 all the way up to 3. There you go. Good. And then range of heights. What's the lowest? 0 all the way up to height of 4. We include 4. There we go. There's our range. All right. Question D. Okay, they want to know the coordinates, ordered pair. Okay, the coordinate of any relative minimum. I will explain what that is. Relative minimum. Or minimums if there's more than one. So the coordinates, I'll put maybe coordinates, there's possibly more than one. Okay, let me describe what a relative minimum or a relative maximum is. I'm going to just get a piece of paper here. Let's say, all right, you don't have to draw this, but let's say we had something like this. Okay. Do you think there's a, just by intuition, do you think there's a relative maximum? What do you think? Do you think there's a relative maximum on this curve? Okay, well, kind of. All right, would you? Well, this goes up forever, right? So I'd say that's a maximum. You can't even tell me what the max is. It keeps going up. But if I asked you, is this point right there, is that a relative maximum? What would you think? Yeah. I would say yes. What is a relative maximum? Well, relative to the points just to the left and to the right of it, it's higher. So I know it's not the absolute highest point because it goes higher, but relative to there and there, I'd say that looks like a max, doesn't it? So that's a relative max. This is a what? Relative minimum. I know it goes lower, but relative to the points just, so that's a relative min. Okay, so that's what a relative min and relative max is. Also, relative mins and relative maxes do not occur at endpoints. Okay, so they do not occur at the endpoints. So this would not be considered a relative minimum. Okay, so if we had to talk about the absolute lowest on this graph and it ends right there, yeah, I'd say that's an absolute minimum. Okay, but we're just doing relative. Okay, so are there any relative minimums on this graph? I would say no, not there, not there. Those are endpoints. So we'll put none. None. Okay. E. What about the coordinates of any relative maximums? Is there a relative maximum? I would say yeah. And where would that be? X comma y. That would be where? 1 comma 1, 4. Okay, it's not an interval notation, it's a location. So 1 comma 4. So there's a relative max right there. Okay. And then one last type of question, and I'm going to put this over here. We're going to write the equation of this piecewise function. Okay, so I guess this is f. So write a piecewise function for that graph. Okay, well, let's see. So f of x equals, that's y equals. How many pieces are there to the piecewise function? Two. We got this one and this one. There we go. All right, so there's two pieces. Okay, let me tell you why this should be easy. Well, the first thing, we've done this before. Do we know how to write the equation of a line? Yes. That's pretty easy, right? We shift it to either one of those two, find the slope, we can find the equation of that line. Can we find the equation of this line? That's our other piece. We have two pieces. That's it. So we have the equation of this line, we have the equation of this line. But, and you've seen this when we had piecewise functions, if we write the equation of this line, we just have to describe where we see this line, right? So, in fact, where do we, in words, where do we see this line in the domain? X from x is what? -2 to x equals 1. There we go. We can write this. And then where do I see this line? From 1 to 3. So if x is between 1 and 3. And that's our piecewise function. All right, so let's go and write it. Okay, so let's write this first equation. And what point do you want to pick? Because it doesn't matter on the line, right?
0, 2.
Okay, so -2, 0. Okay, let's do that. So we need a slope. So what's our slope if we count rise over run? From here to there?
4.
Up how much?
4.
Yeah.
4.
4, up 4, over 1, 2, 3. So that's our slope, right? So 4/3. So 4/3, and then we'll pick this point. So it shifts 2 to the left. So what do I write? X, there you go, plus 2. Do we go up or down? No. So we're good. Okay. We'll put the if we see whatever we see it. I'll get that in a second. Let's go to the second line. We can all write equations of lines. In fact, all these piecewise functions, it could either be a parabola. We know how to do that. It could be an absolute value, v. We know how to do that. So this, we just have to put it all together. All right, so let's do this line. Let's write the equation of our second piece. Pick a point. Which one do you want to use? Okay, 3, 1. Okay, it goes up 3 to the right, up 1. What's our slope? What's our slope? 1, 2, 3, 2. So -3 over 2. And 3 to the right. So x, how do I write that? X minus 3, and then plus 1. There we go. Okay, so we have the two lines, right? Now we just have to put where we see it. So let's go back to this one. And you guys told me we see this from this line from -2 to 1. So let's write that. And then we'll write it like this. So from -2, less than or equal to x. So it's bigger than -2, but less than 1. So now it's our choice. Here we could put less than or equal to, or we could just put less than. I'm going to put less than or equal to 1. So between -2 and 1. That's where we see this graph. All right? And so now, but this other one, okay, we see this graph from where to where? 1 to 3. Okay, so I'll put 1 to 3, but if this one is closed, less than or equal to, this one cannot be closed. So make one closed, one open. So I'm just going to put this one as just open. Okay, and then over here, though, it's between 1 and 3. So is it less than or equal to, or just less than? Okay, the 3 over there. It's a closed circle on this one. less than or equal to 3. So it's between 1 and 3. Okay? And our signs are always, they're always less than, if it's an easy way to look at that. All right? That's it. There's your piecewise function. We have the equation of the line. Where do we see it? From -2 to 1. We have this one. Where do we see this one? From 1 to 3. And that's it. Okay. It'd be nice and easier, I think, if we could just write it like this, interval notation. From -2 to 1. So we could actually go like this, -2 to 1. Okay. And that'd be nice and easy, but they always seem to write piecewise functions like this. So we need to write it inequality as well. So just write it like this. Right like that. Okay? Okay, let's look at one more. Okay, so let me turn this over. So I guess this was number 1. All right, so number 2. Number 2. Okay, let's graph this. So it goes kind of far this way. So you're going to graph actually 7 this way. So 1, 2, 3, 4, 5, 6, 7. Number 1, 2, 3, 4, 5, 6, 7. And then go 2 back. So I'll put 0 there though. -1, -2. And then 3 up. So 1, 2, 3. 1, 2, 3. Okay, so let's graph. So at -1, 3, put a dot. That's going to be a vertex. So -1, 3, put a dot. Okay, so this one's going to be a parabola that opens down. So just open it down and put it, stops there. Opens down to 0. This so it looks like a V, but that's a parabola. Should be more of a curve there, but that's a parabola. Okay, then at 4, 1, put a dot. 4, 1, put a dot. And then this will be kind of easy as well. These are going to be lines. So from 0, 0, draw a straight line to that dot. Like that. Okay. And then from 4 to 7, it's going to be a horizontal line. Okay, so, and that's at 7, 1. 7, 1. Okay, let's put a horizontal line. Okay, it doesn't look too horizontal, but there's a horizontal line. Okay, there we go. How many pieces to this piecewise function? 3. Parabola, a line, and a line. There you go. Okay, so we're going to ask similar questions as the last one. So, question A. Okay, where is the graph increasing? I'll just abbreviate it like that. So let's describe where the graph is increasing. So actually on your own right now, go ahead and describe, again, by only the x-axis numbers, right? Describe where the graph is increasing.
Would you have to use a union?
Yes. Would you have to use a union? Absolutely. So see if you can come up with where the graph is increasing. Always good. So left to right. Describe where it's increasing. Okay. Who thinks they have it right? Who wants to share? Gosh, I forget the name of that. Jessica? Okay. Jessica? Sorry. Jessica, where do you think this is increasing? If you had to describe it. Okay. Negative 2, I'm assuming you meant negative 1? Yeah, okay, there you go. There, it's increasing right there. Yes, from negative 2 to negative 1. Perfect. So negative 2 to negative 1. And also, Jessica says, it's increasing, described by those numbers that you see on the bottom there. It's increasing from 0 to 4. 0 to 4. Okay, do we see that? Okay, looking at a few of your papers, you guys didn't have that, but do you see it now? Okay, good, good. All right, so B, where is it decreasing? So describe where it's decreasing. And, well, okay. All right. So, Max, where would you describe this graph as decreasing from? Negative 1 to 0. That's where it's dropping. Always left to right, so that's where it's dropping. So good. Negative 1 to 0. And then what do you think we call this? It's not increasing, it's not decreasing, it stays the same. And it's constant. Okay, so actually C, you may ask that. So where is it remain constant? Constant. And then, so that would be from 4 to 7. 4 to 7. That's where it's constant. Okay, D, domain and range. Domain and range. Okay, we should be good at these now. Okay, domain. So where, Sam, I'll pick on you again. Sam, what's our domain? Where we see our x value numbers. I'm going to cover up those y values. So where do we see our graph? Describe where we see our graph. Negative 2 to 7. Good. That is our domain. Negative 2 to 7. Okay, and then, Sam, I'm going to keep on picking on you there. What's our range of heights? Okay, there you go. 3 to 0. But with interval notation, we always put the smaller number first, so the lowest, 0 to, there we go, 0 to 3. And Sam, is that a square bracket or curve bracket? Square, because it includes, there is a 0 and there is a 3. There you go. Good, good. Okay, E, relative mins. Okay, ordered pair, location. Do you think there's a relative min on this graph? Is there a relative min? If so, where? 0? 0, 0. Do you think this is a relative min? Raise your hand if you think this is a relative min. 2, 3, 4, 5, 6. Raise your hand if you think, no, that's not a relative min. Okay. Raise your hand if you don't know. Well, probably everyone else. Okay, the honest ones, good. Raise your hand if you don't care. I'm just kidding. Put your hands down there. Okay, this is a relative min. Why? Because relative to the points just left and right, it's lower. So that is a relative min. So 0, 0. There we go. That is a relative minimum. Question?
Negative 2 is not because it doesn't have anything to the left of it.
Correct, and it's an endpoint. Relative mins, relative max, yeah,
Can't be an
and that's,
endpoint.
yes, can't be an endpoint. Can't occur at an endpoint. Good. Okay, F, relative max. Okay, where's the ordered pair? Where is their relative max? At,
3, 1.
or something, common something?
3, 1.
Well, 3 1s over here.
Oh, negative.
There you go. Negative 1. There you go. So negative 1, 3. Well, is that a relative maximum?
No.
And why not?
Because it doesn't drop.
There you go. Relative, it's got to be higher, but it's the same on this side of it. It's lower there, but it's the same on that side. So that's our only relative.
Point was 0, 7. That would be another one?
Or 7, 0?
Yeah, 7.
Yeah, and it went down? Yes, it would, because it'd be kind of the higher point. Exactly, exactly. Okay, so I'm going to put G over here. All right, so you said that there's 3 pieces, so let's write the equation, piecewise function. So y is equal to 3 pieces. Again, we know how to do this. We know how to write the equation of a parabola. We've done that. We definitely know how to write an equation of a line. We just did that. And we know the equation of this line. Perfect. Okay. So let's go ahead and write the equation of this parabola, this piece. Okay, I'm going to do it up here, just so some scratch work. All right, so let's write the equation of this parabola. Hopefully we know how to do this because we just took a test on it. Okay, so y equals, so we need to write the equation of this parabola. We know how it shifts. It went 1 left, up 3. Okay, so tell me what to write. I'll move my pencil. Tell me what to write. A, because we don't know that, we'll find that. Parentheses, x, one left.
Plus 1.
Good, plus 1.
Plus 3.
And then up 3.
Squared.
And then we got a square. There we go. Okay. No, I just yeah. Okay, left 1, up 3. Got it. And we just have to find the A. Well, how do we find the A? Plug in a point. Good. So what point do you want to plug in? Okay, don't plug in the vertex. It's one other than that. So I'd say 0, 0. We could plug in -2, 0. How about we do 0, 0? Okay, 0, 0. So 0 is your y equals A, 0 plus 1 squared plus 3. Great review on just writing an equation of a parabola. Right? Okay, so we have 0 is equal to 1 squared is 1. So I'm going to put it there just because it's 1 plus 3, just to, not that you would fall for this trick, but do I add 1 and 3? No. Okay, because that's tied with its multiplication. So what's our A? -3, subtract 3. So A equals -3. All right, so let's write our equation right here. So we have -3 x plus 1 squared plus 3. There we go. In fact, let's go and write this. Where do we see this parabola from where to where? -2 to 0. Good. -2, do this, x. We'll include 0 on this one. So that's where we see the parabola. Okay, now let's do these. Let's do this line. So we'll slope. What's the slope of this line from this point to this point? Good, up 1 over 4, right? So y equals 1/4, and then, well, we get a choice. What point do you want to pick? Right there, 0, 0. So 0 left and right, and 0 up and down. So 1/4, there's 0 left, 0, there it is. That's our line. Okay, where do we see this line from? Okay, you guys still with me? You guys? Okay, from 0 to 4. That's where we see this line. We could have chose this point as well. It just looks a little different. We chose this one. It's nice and easy. Okay, so from 0, now what do I put here? Just less than, because this one's less than or equal to. So we don't want to double up there. X, and then our choice. Oops, already, I don't want to erase. Okay, so we'll do between 0 and 4, but including that 4. There we go. There's 2 pieces of the 3 pieces that we need. Okay, what's the equation of this line? 1. Y equals 1. There it is. Well, where do we see this? From 4 to 7. Okay, so 4 like this, don't it? Because that's an equals there. Just don't make it there. So 4 to, now on this one, do we include 7? Yes. So I put less than or equal to 7. So between 4 and 7, y equals 1. All right, so how does that look? Okay, good. Did we understand that? Okay, a lot of students say this is the hardest stuff. But do you think we can do that?
Yeah.
I think we can. Because we did so well last unit, makes this unit easier, right? If you're still struggling with it, well, guess what? We can always learn. We can always, right? Okay, your homework packet, I need to hand that out. And then we may look at, we have about 8 minutes, 6 minutes? Okay, we're going to start, I think, number 3. So I'm going to turn this off just for a sec.